Yeah, thank you very much for the kind introduction, and thank you very much for inviting me here to speak as part of the Alexander von Humboldt Lecture, which is obviously a great honor for me, but an even greater pleasure to do so. As the title of my presentation already indicates, I'm going to talk about misunderstandings. And I'm going to talk about misunderstandings as a very productive and important part of the applied sciences. And you know, some of you might know a little bit about my background and have been introduced just now. My background is in organization and management studies, which is commonly considered an applied science, or has very applied parts, or is expected to have very applied parts to it. And as in most applied social sciences, there have been huge criticisms about an apparent lack of relevant knowledge. Apparent lack of the creation of knowledge that practitioners can actually use. And this has triggered a huge debate within organizational management studies and also other parts of the social science. How should we deal with this problem, or this perceived problem, of not producing knowledge that practitioners find useful, knowledge that practitioners are using? I've been myself very much involved in this debate, and what I'm presenting here is also part of my position in this debate. And together with Alfred Kieser and Alexander Nicolai, we've put forward a position in this debate which essentially argues that the debate is fundamentally flawed. The debate is fundamentally flawed in the way that it conceptualizes the relation between applied science and practice. And the argument basically is there is a lot of misunderstanding in this debate. So let me just start with an overview of my presentation today. So I start off saying a little bit about this claimed lack of practical relevance in organizational management studies in particular, but in the applied social sciences more generally, and talk a little bit about the problems that have commonly been identified as reasons for this relevance problem, and the solutions that have been suggested. And I want to argue and show that the solutions that have been suggested are somewhat problematic. They sound intriguing, but they are highly problematic, as I think. Then I'll talk a little bit about social science as a self-referential discourse. So how should we conceptualize social science, and what are the social sciences? And this is important in order to be able to speak about potential relevance of the social sciences. Then I'll talk about the barriers, potential barriers of transfer of academic knowledge, scientific knowledge, into other spheres of society, into practice. In the fourth point, I'll talk about adoption of scientific knowledge by practitioners as necessarily based on misunderstandings. And then I conclude what this all means for the conceptualization of the social sciences. So that's the program for today. And I'll start with my first point, and just to illustrate sort of the discussion exemplary, I have looked up a couple of quotes from the presidential addresses, the yearly presidential addresses of the Association of Management Scholars, where the president usually highlights important issues. And as you can see here, an important issue every year, again, an issue that is repeated year after year, is lack of practical relevance. We have to do something about practical relevance. So just to give a couple of quotes, so 1993, in the presidential address, it is time for us to break out of our closed loop. It's time for us to matter. Then 99, management science will be increasingly seen as counting angels dancing on the head of a pin. So dealing with unimportant, not practically relevant issues. And Andrew van der Ven says findings from academic and consulting studies are not useful for practitioners and do not get implemented. So every year again, the same story again and again, calls to close the gap between management science on the one hand and management practice on the other hand. So repeated year after year, but management science has not become more relevant over the years. Some would argue it's even worse. It has become even less relevant. So what are the problems, or what are the reasons for this apparent lack of relevance of management knowledge produced by management scientists? You can group these identified problems and the suggested solutions into two areas. On the one hand, they argue that's the knowledge transfer problem. So the knowledge generated by science just doesn't get transferred to practice. It never reaches practitioners. And the other issue identified is that the scientific knowledge that is produced by the management scientists is not the right knowledge. So there's a problem in the kind of knowledge that is being produced. And there are suggestions to deal with these kinds of problems. So in terms of the knowledge transfer problem, a lot of people have argued that just the language is too difficult. It's a scientific language that cannot be understood by the practitioners. So we have to simplify the language. We shouldn't use jargon and so on. And by changing the language, we make our scientific results more accessible to practitioners. Also, somewhat connected to that, we need to build the infrastructure for this transfer. We have to publish in practitioner outlets. We have to organize workshops in which we disseminate the scientific knowledge to the practitioners. And many more similar suggestions. On the other hand, there are solutions, suggestions of solution to the knowledge production problem. So we need to produce other kinds of knowledge. So we need different research designs. So some people are suggesting we need more qualitative research rather than quantitative research. Research that gets closer to what the practitioners actually do, and that will then be also relevant to practitioners. There's also a suggestion that maybe the problem is that we get the wrong incentives as scientists. We're incentivized to contribute to science, to theories, but we're not incentivized to contribute to practice. We need to put other incentives. We need to have, for example, promotion of academics according to the contribution to practically relevant knowledge. Also, suggestions that editorial policies have to be changed. So rather than just reviewing papers according to the contribution it makes to theory, we need to evaluate it or review them according to the contribution to practically relevant knowledge. Also, a suggestion that we are going to talk tomorrow about and discuss tomorrow about is the suggestion to do more collaborative research, to collaborate with the practitioners. And that will help us to develop research questions that are ultimately also relevant to practitioners. And many more suggestions that have been put forward. All of this sounds very logical, very reasonable when you look at it. There's a beeping sound, no? OK, so it's better like this. Sorry for the beep. All of this sounds very reasonable, and it seems like there's hope for the applied sciences to produce more practically relevant knowledge. However, most of these suggestions, there's still this beeping noise, no? However, these suggestions are not new. And most of the suggestions go back into the 70s. You can find variations of these suggestions in the 1970s. And the question then is, if these suggestions have been around for such a long time, and they seem not too difficult to implement, why haven't they been implemented? And also, the relevance problem has gotten worse over the years, even though we have these suggestions. And also, you can find similar problems and similar suggestions across all applied social sciences. So the question is, why hasn't it been adopted if the relevance problem is such a big issue for the social sciences? And the argument here is the problems are more fundamental than these suggestions seem to suggest. This might have something to do with the very nature, very logic of the social sciences as such. And I'll try to make the argument for that. So let us look at the notion of science that is underlying much of these, or a lot of these suggestions and identified problems. I would argue, and a lot of people are arguing, that it's a very simplistic notion of the social sciences as underlying a lot of these suggestions. And I'm doing a little bit of a caricature here, so I'm exaggerating a bit, but just to highlight the central points. So most of the discussions, most of the contributions to the relevance debate are based on a concept of the practice of the science-practice relation as, first of all, based on the assumption that we can generate knowledge that is context independent. Knowledge that can be taken out of the context in which it was developed and just put somewhere else. So scientific knowledge, knowledge generated within the scientific discourse, can be taken out of the scientific discourse and moved into the practice realm and applied in the practice realm. Second assumption is knowledge produced by science is better knowledge than knowledge that practitioners have. So knowledge produced by scientists, scientific knowledge, should replace knowledge of the practitioners. And this leads to, I emphasize again, it's a caricature a little bit, to a so-called aqueduct model, or Alexander Nicolai called it the aqueduct model, according to which you have, particularly for the management sciences, you have the relation between management science and management practice, a little bit like an aqueduct, where you have science sort of at the top end of the aqueduct generating knowledge like water that then more or less naturally would flow down via management consulting to management practice. And if you have a problem in terms of relevance, that problem can be traced back either there's no water produced, or wrong water produced up there, or alternatively, there are some obstacles, some barriers in this aqueduct, because otherwise the knowledge produced there would more or less naturally by itself flow down. With little help maybe, but it is more or less a natural flow. However, this simplistic notion might be the reason why we have not been able to tackle the real relevance problem. That's why we have not been able to really engage with the issue of practical relevance. And the sociology of science provides much more sophisticated models that might help, and which I will also put forward, might help to show where the real problem of the relevance problem lies. So let me now get to my second point, social science. What is social science, or what is science, and what is specific about science? And this is important in order to talk about the relevance problem. Well, the traditional conceptualization of science is science as a scientific community. When you think of Thomas Kuhn, he talks about scientific community, a group of scholars, and particularly a group of university professors as prime example of the researcher who produces knowledge. Somewhat related view is science as academic institutions, so the space within which science is produced. So it's the university, it's the business school, it's research institutions. Both of these more conventional, traditional conceptualization of science, however, have the problem that they obscure part of the relevance problem. Because if you talk about the professors or the scientific researchers, a group of people as producing scientific knowledge and representing science, then you see that a lot of researchers, a lot of professors actually are engaged in practice. Particularly in the world of management studies, you see a lot of professors doing consulting work. So is that then a sign of science engaging in practice? Similarly, you see that academic institutions, you see practitioners enrolling in academic institutions, in business schools to get degrees, to get executive education, and the numbers of people getting degrees, practitioners getting degrees at such institutions is increasing, and increasing dramatically over the last 20 years. While at the same time, the criticism of a lack of relevance is getting worse. So a conceptualization of science in terms of scientific community or academic institutions is not very helpful. Much more helpful is to look at it as a particular kind of discourse. Science as a specific discourse. What kind of discourse? It's a communication of scientific knowledge. The communication of scientifically approved knowledge. And where do you find that kind of communication? Where is it taking place, this kind of communication? It's taking place particularly in journal articles. So journal articles as the prime location for the scientific communication. But you also have other forms of published, so the scientific discourse is taking place particularly in form of published works, and next to academic articles, obviously you also have books and book chapters, but the communication is moving more and more into into the journal format. And what do you have there? You have the cross-referencing, the cross-connections between different scientific works. And that's what is particular of the scientific discourse. So let me just do a little detour before I continue about the scientific discourse, just to talk a little bit about knowledge versus scientific knowledge. So what is scientific knowledge compared to other kinds of knowledge? When we talk about science as a scientific discourse, or the communication of scientific knowledge, what is the difference to other kinds of knowledge? Well, basic concept of knowledge, you could say knowledge is a result of a condensation of observations. So you make observations, and these observations are then condensed in some form of relations between different concepts, categories, or whatever. So you might observe, in my area, for example, if you increase the volume of production, the cost of production per piece decreases. You observe this, and then you, from this, you condense the knowledge about certain knowledge about the relation between volume of production and cost of production. Okay, and that then might guide you in other observations, about employment figures and so on. So you use that knowledge also to guide other observations. Such kind of knowledge doesn't only exist in the sphere of science, it exists amongst practitioners. Practitioners have knowledge about the particular customers, about the production systems, and so on. So we have knowledge also outside of science, often referred to as experiential knowledge as compared to scientific knowledge. So what is then particular about scientific knowledge? You could say scientific knowledge is true knowledge. It's knowledge that has been coded as true. It is knowledge that has been tested or assessed according to scientific criteria as true knowledge. And that knowledge then is stamped as true knowledge. It's marked as true knowledge or coded as true knowledge. So true knowledge is not knowledge necessarily that corresponds with some outer reality, but it's knowledge that has been assessed and found to be fulfilling the criteria according to which it has been assessed. So what is particular about knowledge that has been coded as true knowledge? Well, you could say lots of people come with knowledge claims. The question is always, do you accept the knowledge claim? Somebody is coming up to you and say, this and this is related in that way. Do you accept that? Particularly when you think somebody else is coming and telling you something else about the relation between two components. Well, when do you, the difference here with scientific knowledge is that once it's stamped, it's marked, it's coded as true knowledge, you are more likely to accept it. So truth in this case functions as a generalized, so-called generalized symbolic communication medium, similar to power. Power is also a symbolized general communication medium. If you communicate something and you have the respective power, then the other person is more likely to accept what you're saying. So same way here, if you have a knowledge claim and you mark this knowledge claim as scientifically assessed knowledge, then it's more likely that the other person will accept that knowledge claim. So that's what differentiates scientific knowledge from other knowledge, for more experiential knowledge. Okay, now let me get back to the scientific discourse as a communication of scientifically approved, scientifically assessed knowledge. Well, if we say that scientific knowledge is knowledge that is coded as true knowledge to the extent that it has passed through or has fulfilled certain criteria or has been assessed according to criteria, specific criteria, scientific criteria. Well, you're only going to accept that knowledge claim, if you accept the criteria according to which the knowledge has been approved. So the acceptance moves from accepting the knowledge to accepting the criteria. So what criteria would you accept as valid criteria for assessing knowledge as true knowledge? Well, you probably would accept criteria that themselves are based on knowledge that has been assessed as true. So you need assessed knowledge for creating criteria for assessing knowledge claims. And what you see here, this ultimately leads to some referential closure. So you need scientific knowledge to generate criteria according to which scientific knowledge can be assessed. and approved. So you have necessarily a recursivity or a self-referentiality in the scientific communication. Also empirically, you can observe that academic disciplines, as they develop and mature, become more and more self-referentially closed and develop more and more this self-referentiality. So for example, in my area, I'm also interested in strategic management as an academic discipline. When it started out, it was very academic. It based a lot of its knowledge claims on experiential knowledge. And the more it developed and became academic, the more it matured, the more it developed theories and methods according to which it assessed its own knowledge claims. So, and these knowledge claims, the assessed knowledge itself, then serves also as a program for developing further knowledge, for developing more theories and more methods. Now, just to underline this recursivity and this self-referentiality, I said that we develop theories as assessed knowledge claims. Well, how do we develop them? We develop them on the basis of methods. So we have methods that help us generating theories or are involved in generating theories, in assessing the truth value of theories, and these theories themselves then contribute to developing methods according to which we can then again generate theories. As you can see here, and also exemplified in this particular model here, is we are dealing with an incestuous closed loop. I mean, that's the criticism, but we would say that criticism is to some extent true. It's not incestuously closed in the sense that it doesn't allow to react to anything outside science, but it is a fundamental self-referentiality which is necessary for science to work. Just to go back again, we need scientific knowledge in order to develop criteria for assessing scientific knowledge. And that's the fundamental basis on which science is based. This obviously also leads to some path dependence of research on earlier research. Now, all of this then leads to some kind of decoupling of scientific observations, the way that scientists observe the world from the way that other people, practitioners, observe the world. And I'll just highlight 3 points of this decoupling. The first one is, well, in order to assess knowledge claims according to certain criteria, the knowledge claims cannot be too complex. So in order to be able to assess knowledge claims about the world, you have to dissect the world in a way that you come up with knowledge claims that can actually be assessed. So what happens in science is you decompose empirical reality, you decompose the meaningful totality of the world as experienced by the practitioner, you decompose it into different aspects. So you have sociologists focusing on sociological aspects, you have psychologists focusing on psychological aspects, you have economists focusing on economic aspects, whereas the practitioner would say, well, all of this together makes my experience in this one situation. But science has to do this in order to be able to come up with knowledge claims that can be assessed as true. The second point is, in order to be able to make knowledge claims that can be assessed according to criteria of scientific criteria, you also have to base your knowledge claims on counterfactual assumptions. And the prime example here is ceteris paribus. The assumption, everything else stays the same. You can concentrate on a particular issue. This is a counterfactual assumption that is explicitly acknowledged in science. So scientists are aware that this doesn't correspond with anything out there. The world is never the same. You can't just stabilize the other elements. So just to give a quote from Niklas Luhmann, the assumption of ceteris paribus is the condition of isolating the objects of research, but it is a consciously false assumption. Consciously false assumption. Only through false assumptions can true knowledge be attained. Okay, next point. Now, important issue is, issue that has been discussed a lot, is scientists should deal with problems or should find solutions to problems of the practitioners. The practitioners have problems and scientists should take these problems as the research problems, the problems they are doing research on. And a lot of research is initiated with a practical problem and also gets funding on the basis of the assumption that the researchers might be able to find a solution to a practical problem. However, what happens, and here just a quote from Kieser-Nicolai, which actually points exactly to that problem. Sometimes studies are triggered by a problem that plagues practitioners. Soon, however, the discussion between researchers via their publications creates new and different problems, and the problem that initiated scientific discourse gets lost from sight. So what the scientist does, the scientist has to reframe the practitioner problem in terms of a theoretical problem. Because if you don't reframe it in terms of a theoretical problem, you can't base your knowledge claims on other theories and sort of in that way support your knowledge claims and test it according to criteria of scientific truth. So necessarily, the scientist will reformulate the original problem, the original question, in terms of a theoretical question that then might not have much to do with the original question that the practitioner had. So just to summarize, the science dissects phenomena in the world in such a way as to render them subject to scientific criteria of truth or untruth. Okay, let me just close this part with another quote by Kieser-Nicolai, emphasizing particularly this disconnection between science from the world as it is experienced by the practitioners out there. In short, in discourses in which researchers try to establish the validity of theories on the basis of scientific criteria, science necessarily disconnects itself from discourses in which practitioners evaluate the usefulness of a concept. Again, the practice-oriented researcher finds himself or herself thrown back on that self-referential stream of communication that is typical for scientific discourses and is perceived as detached from the real world. So science cannot but detach itself from the world as experienced by the practitioner. So this takes me to the third part, in which I want to talk about barriers to transfer of knowledge. So if you look closely, the last part, the second part, is very much about the knowledge production problem, as some would call it. So what kind of knowledge is being produced? And now we're looking at the way that the knowledge that is produced potentially gets or doesn't get transferred to practice, or to areas outside science, to other spheres of society. Well, let me start first. I want to highlight three issues here. The first one is, when we look at science and we look at practice, we're dealing with different kinds of logic of knowledge production and of knowledge use. And I'll just draw on the example of management science and management practice, and I'll quote from James March, who's one of the classics in our field, one of the classics of management studies. And he compared management science and management practice, or the role of knowledge in both domains, very fittingly. Just here, I start with logic of knowledge creation and management science, which sort of repeats now a lot of what I've said before. It's aimed at the creation of knowledge for its own sake. So science produces knowledge for the sake of producing knowledge. It's typically general, timeless, unspecific knowledge. Well, that's the claim behind knowledge. And this knowledge generation is guided by scholarly standards and scholarly rules, the methods and theories we talked about before. And it's aimed at generating true knowledge, knowledge that is considered true, or knowledge that can be coded as true. Now, this is very different from the world of the practitioner, particularly now in management practice. What is the management practitioner aimed at? What is the logic of management practice here compared to management science? Well, this is aimed at solving practical problems, aimed at decision making. So we need knowledge that helps in solving practical problems and in making decisions. It's typically context-specific, local, time-bound knowledge that is needed. It's experience-based and not methods or theory-based. And what's the central criterion for knowledge in practice? Usefulness. What you need is knowledge that is useful. Knowledge that helps you solving your problem. Knowledge that helps you to make your decision. So all of this, just to boils down to, we are dealing with different types of knowledge here. True knowledge is not necessarily useful knowledge. And more importantly, useful knowledge is not necessarily true knowledge. And when you look into practice, you see a lot of practitioners working on the basis of knowledge that from a scientific point of view is not true and would not hold in a scientific context. But still, for the practitioners, it's extremely useful. So that's the first point. The first barrier to the knowledge transfer is the different kinds of logics that we're dealing with. Now, a second problem to the knowledge transfer is that the practice domain, the sphere outside science, is not an empty space in which you can just put your knowledge or transfer your knowledge, but it's a pre-structured space. A space pre-structured in terms of existing knowledge structures. So practitioners have their knowledge. They have knowledge about different things. So if you try to transfer scientific knowledge into the practice domain, it's not that you can just put it there, but it would replace other kinds of knowledge. It would have to be integrated in the knowledge that's already there. And replacing knowledge is not just an automatic process. More importantly, also there are structures of power and interest. So knowledge would have to be integrated into the existing power and interest structures. Think about, take the organization with particular structures of authority. And there are theories now that undermine these authority structures in terms of their usefulness. And you can imagine that top managers would not be very welcoming to a theory that undermined the relevance in the organization. So theories about the hubris of top managers and how this hubris is detrimental to the organization are likely to be met with resistance from the top managers. And finally, a third point, we have an ongoing stream of communication in the organization. So we have communication, an ongoing communication process structured around, organized around topics. So any scientific knowledge that want to enter into the stream of communication has to fit with the topics that are being discussed. It's not that you could just start the communication there. The communication is already ongoing and has to be fitted somewhere into that. So it has to fit with the topics that are already there. So this is the second obstacle to the transfer of knowledge to practice. Now come to the most important one, the most fundamental one, which is the context specificity of meaning. The context specificity of the meaning of knowledge. Knowledge is always context specific. So you can only understand knowledge in the specific context in which it is embedded. Now think about scientific knowledge. Scientific knowledge is knowledge about how concepts, theories, theoretical streams are relating to each other. If you take away the theories and the concepts, the knowledge as such has no meaning. So you can only understand the knowledge, the meaning of the knowledge, if you relate it to the theories around it. So if you take the knowledge out and try to transfer it somewhere without the theoretical context into which it's embedded, the knowledge would not be the same knowledge. So because of that, Teubner said interdiscursive translation is impossible. You cannot translate. It's not a question of translating, putting in different words and explaining it. It is you cannot translate knowledge from one discourse into another. Interdiscursive translation is impossible. Between discourses, the continuation of meaning is impossible. So it would not be the same, would not have the same meaning if you transfer it somewhere else. So in that sense, it's not possible to speak about the transfer of knowledge from one discourse to another discourse. Now, let me get to my fourth point about the adoption of scientific knowledge. So what does all of this mean for the science-practice relation? And what does it mean for those few examples that we might know where scientific knowledge actually got adopted in a practice context? Is this just an illusion, or what is it? is the scientific discourse closed off from the rest of the world, or what is going on there? And the argument is we're dealing with misunderstandings here. There is communication, there is the adoption of scientific concepts into practice, but this is based on misunderstandings and will inevitably lead to misunderstandings. So when we look at descriptions of the transfer of scientific knowledge into practice, we often find that researchers refer to some kind of change in that knowledge. People talk about knowledge conversion. So when knowledge gets transferred, it gets converted. They also talk about cognitive conversion, another term for that. Or they also talk about reinvention. Some kind of reinvention is taking place there. So transferring the knowledge is in some way changing the knowledge. So Alfred Kieser says translation attempts inevitably, and the important point here is the inevitably produce different stories. So the same story told in the academic context is a different story if it gets told in the practitioner context. And just to illustrate this with a simple example, there was an experiment by two colleagues of mine, Paula Jasakowski and David Wilson, and they had some practitioners. They invited some practitioners into their classroom. They explained them some theories, explained them the background to the theories, took quite a long time to explain these theories, and then asked these practitioners to use these theories or concepts from the theories in the practical context, to look how they would deal with these concepts that they were introduced to in the practical context. And they found that these concepts were used in completely different ways and took on different meaning from the original scientific meaning. In particular, this was in the area of strategic management. There are certain concepts about the environment, about stable environments and turbulent environments, and some concepts about the stable environments were used as concepts for exploring the dynamism of environments. So were used in completely different ways from the meaning these concepts had in the scientific context. So in the adoption of knowledge, the knowledge is changed. So you cannot adopt knowledge, transfer knowledge, but the knowledge gets changed in the process of adoption. So Luhmann also refers to this as, or we can refer to this also as non-identical reproduction. So when knowledge from science gets transferred or adopted in the practice context, the knowledge does not get reproduced as the same knowledge, but it gets reproduced as a different knowledge. And Luhmann says, so non-identical reproduction thus means a change of meaning, the meaning of the knowledge, through recontextualization, through integration into a new neighborhood, and through triggering of different associations. So the same knowledge triggers different associations in the practice context, and as such becomes a different kind of knowledge, becomes different knowledge. So whether the infused element was true or untrue, ultimately is completely irrelevant. So it's not just the question about an incorrect transfer of knowledge from science to practice, but actually in this transfer, in the adoption of knowledge, new knowledge is created. And just to give you another quote, one discourse from Teubner who emphasizes this creation of new knowledge in this adoption process. One discourse cannot but reconstruct the meaning of the other in its own terms and context, and at the same time can make use of the meaning material of the other discourse as an external provocation to create internally something new. So in the adoption of scientific knowledge, the practitioner produces new knowledge. So overall, you can say adoption of knowledge is based on a misunderstanding, which leads to the creation of new knowledge. So if we follow this logic, we can say relevance of scientific knowledge is not determined by science, but relevance is determined by the adopting system, the adopting context. So since it's the adopting context that creates the new knowledge, it's the adopting system that ultimately is responsible for that. So science has no control over the effect its knowledge has on practice. The effect is entirely determined by the specific practice context. So James March, who I've been referring to a couple of times in this lecture already, he's one of the important management scholars who has developed a lot of scientific concepts about organizations. He was once asked, so how relevant is the knowledge he produced? And he said, it would not be fruitful to ask me, as a scientist, about the immediate usefulness of what I had to say. If there is relevance to my ideas, then it is for the people, the practitioner, who contemplate the ideas to see, not for the person who produced them. So it's ultimately the receiving, the adopting system, the adopting context that ultimately determines what relevance the knowledge has in that context. So if the question of the misunderstanding and what kind of process of misunderstandings get triggered is ultimately determined by the adopting system, then the adopting system also is responsible for the positive or detrimental effects it might have. So whether adopted scientific knowledge ultimately leads to positive effects or negative effects is to a large extent the responsibility of the adopting system. And here just another quote from Teubner. He said, there is of course no built-in guarantee that such misunderstanding between different discourses, between science and the adopting practice context will be productive. You cannot say in advance whether in the famous shell the irritation of the sandcorn will at the end create the pearl. So the relation between science and practice is like sand and the shell. A sandcorn can trigger in the shell the process that leads to the creation of a pearl. But the sandcorn is not the reason for the pearl. It cannot determine the pearl itself. So this then leads to the question of under what conditions will a sandcorn trigger the production of a pearl? Under what conditions will scientific knowledge provoke the production of practical knowledge? And that's very much a question of resonance, as Luhmann says. Resonance. Does the scientific knowledge resonate in some way with the practical world? Or does the scientific knowledge create some resonance in the practical context? Does it trigger some associations because of which it would then produce some new knowledge? So scientific knowledge needs to resonate with the practical context in which it gets embedded. And only by creating some resonance will some new knowledge then be produced. So the word resonance, or the term resonance, implies that you have structures and processes of the adopting system that determine the extent to which a system can and will react to scientific knowledge. And this is helped, as some have shown, if the scientific concepts are open to different interpretations, if they have interpretive viability. One issue that is often deplored in management science, or also in applied science more generally, is linguistic ambiguity. The concepts are not clearly enough defined. But linguistic ambiguity can give conceptual terminology flexibility. Flexibility to be interpreted in different ways in the practical context. The more open a concept is to different interpretations, the more likely it is that practitioners can, or that some associations will be triggered in the adopting system so that new knowledge can be will be created. So this now leads me to the last part. So where does all of this take us in the discussion about practical relevance? What implication does it have for the way that we should think about applied sciences? Well, let me start. The first point, the first most important point, is that the metaphor of closing the gap between science and practice, And this call with this metaphor, we need to close the gap between science and practice, is misleading. It's misleading because the gap is constitutive for science. If you dissolve the self-referential process of science, you would dissolve science. So science could not produce true knowledge, knowledge that is coded as true, if it wasn't based on this self-referential mode of operation. One point that is often emphasized also is that even though theories and methods sort of detach us from the world out there, from the way that the practitioners experience the world, these theories of and methods are also sometimes helpful in preventing us getting entangled in the practitioner's world. And as Luhmann says, the theoretical repertoire of the scientific system, the theories and methods, can be understood as a means for preventing that the scientific system gets entangled, or the scientific study gets entangled in the structures and operations of its object of investigation. Science mustn't fall for its object of investigation. So it needs to keep the distance, and part of keeping the distance is the theories and methods that are forced on us by science. Obviously, this makes it difficult to engage directly with the practical world. This makes it difficult to come up with solutions directly for practical problems. But the question is, do we as applied science really have to solve practical problems? Isn't the solving of practical problems, particularly in the management area, isn't that the domain of consultants? Isn't that what consultants do? And here just a juicy quote from James March. Also, when asked about developing solutions to practical problems, and he has done lots of research on on organizations and how organizations work and why they work as they do. He said, no organization works if the toilets don't work. But I don't believe that finding solutions to business problems is my job as a researcher. So the expectation of applied science as solving practical problems, you could argue, is misleading. This is the domain of consulting. That's not the domain of science and neither of applied science. So the implication for the way for the applied sciences directly is then, first of all, that the first and foremost emphasis and focus of the applied science has to be the contribution to the advancement of scientific knowledge. It's not a dual focus of relevance and contribution to science. The first and foremost focus has to be the contribution to science. And in that sense, Augie and March also warn and say there's reason for caution about relevance in the applied sciences. However, and that distinguishes the applied science from basic sciences, is that there's a scientific reflection also, or has to be a scientific reflection on the potential for such secondary adoption by the practical world. So the applied science has to reflect that the knowledge it produces should be possible to be adopted by other areas outside of science. And for that, it has to ensure the possibility of some resonance, ensuring that there is some resonance with the results that the scientific process produces and the practical world out there. And that can be done through structural coupling. So, for example, by structuring scientific programs analogously to the way that the practical world seems to be cut up. For example, in management studies, you can find subdisciplines of management, like HR, like strategy, like accounting, even though they might mean different things, but at the same time, they trigger associations, are able to trigger associations in the practical areas. And finally, applied science needs the fiction, needs to be based on the fiction that its results can be transferred into practice. Without that fiction, the applied sciences would just decouple completely from the world as experienced by people by the ordinary practitioner. So it's necessary to treat scientific knowledge as if it was directly relevant to practice. practitioners. That's a point that my colleague Andreas Rasche emphasized. Now, what does this mean? What does this mean now for the role of the adopting system, for the role of the practice domain outside of science? Well, one implication of this is that you have to acknowledge the constitutive role of the adopting system. The effects of the adoption of scientific knowledge in the practical system into which it has been adopted is ultimately the product of the adopting system. It's under the control of the adopting system and not under the control of science that has produced the knowledge. This has the consequence that the adopting system also has to take responsibility for the effects. If the knowledge that is produced by in this adoption of scientific knowledge, and if the effects that this newly created knowledge has in the adopting system is ultimately determined by the adopting system, then the adopting system has to take responsibility for the effect. And this then leads to a dilemma, an important dilemma. On the one hand, we said there's a necessity of a fictional belief in the transferability of scientific knowledge. So if the practical domains, if the practitioners did not believe in the possibility of transferring scientific knowledge in the practical domain, if they acknowledge that it's just their own product, they would not care about scientific knowledge. And on the other hand, they have to accept and acknowledge the constitutive role in producing the knowledge as a result of, or in the misunderstanding of that knowledge, in order to take responsibility for the effect that the adopted knowledge has. If it did not acknowledge its own constitutive role in creating that knowledge, then it would be a blind process without anyone or anything controlling for it, without anybody controlling the effect. So we have a dilemma here. On the one hand, you have to treat the scientific knowledge as if it could directly be transferred into practice, and you have to treat, on the one hand, the knowledge that arrives in the practice domain as if it was the same knowledge that was created in science, and at the same time you have to acknowledge that you produce in this misunderstanding this knowledge. And how can you reconcile both of that? In some form of hypocrisy. Some form of hypocrisy where you pretend that the knowledge is transferred directly, but at the same time you acknowledge that it's your own product. Now, let me get to the conclusion in which I want to summarize the main points, which brings me back to the title of my lecture. The productivity of the misunderstanding of applied science. In summary, my talk addressed two misunderstandings. The first misunderstanding is the misunderstanding of applied science as producing knowledge that can be directly applied in practice. As argued, applied science knowledge from the applied science cannot be directly transferred. It's a misunderstanding. Second misunderstanding is that misunderstanding is a central mechanism in the adoption of scientific knowledge. So misunderstanding is the mechanism of adopting knowledge and thereby producing new knowledge. However, both of these misunderstandings are necessary for applied science. They're necessary, and in that way also productive. Thank you very much.